I realize you might not be completely done with these yet, but let's go ahead and take a look at them, see how you've done on them so far. Um, the first two here are graphing, and of course these are ellipses. That's what we were working on last Wednesday. So for the first one here, to graph this ellipse, first thing we need to find is where the center of it is. Center of this one's going to be at 2, -3. So I'm going to make my grid here appropriately. There's the center of my ellipse. Now the 16 here, if I take the square root of 16, that's 4, which tells me my horizontal axis, my semi-horizontal axis is 4 units long. So I go 4 units from the center and put dots, and that's where that axis ends. The 25 here says my vertical semi-axis is 5 units long. So up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So my oval, oops, I didn't do that very well going to the right there. Let's try that again. Is slightly elongated in the vertical direction. If I wanted to find the foci of that, remember it is a squared minus b squared equals c squared, where a is the larger of the two axes. So that would be the 25 is a squared. 5 is the semi-axis. Minus b squared is 16. That gives me 9. So c squared being 9, if I take the square root of that, tells me that c is 3. And that focus always goes in the direction of the major axis. So 1, 2, 3, there's one focus. 1, 2, 3, there's the other focus. So my foci are at 2, 0 and at 2, -5. Sorry, -6. So those are my foci. Number 2 here requires a little bit more work. Now I realize number 5 was cut off. We'll come back to that one when we're done here. But number 2, I've got to group the x's together. So I've got 4x squared minus 24x. And I'm going to go ahead and factor out that 4. So x squared minus 6x. Then I'm going to group my y's together. I've got 25y squared plus 100y. And I'm going to go ahead and factor out that 25. So I've got y squared plus 4y. Then I'm going to subtract the 36 from both sides, so that this equals a -36. So now I have to go through and I have to complete the square for both the x and the y terms. For the x terms, this is a -6, so we divide that by 2, which is a -3. Then we square -3 to get 9. So it has to go in here as a 9. Now what we added was 9 plus 4, or 9 times 4, which is 36. So I have to add 36 to the far right side as well. For the y's, this is a 4 here. So I divide that by 2 to get 2. And then I do 2 squared, which is 4. So I have to add a 4 in there. But what I added was 4 times 25, which is 100. So now, on the x squared terms here, this is x minus 3 squared is what that becomes. Still times the 4. Then I've got 25 times, this is y plus 2 squared, equals -36 plus 36 plus 100 is 100. And now I have to divide by a common denominator. I need to make this 1. So I'm going to divide by 100 to make that into a 1. So I divide each of these by 100. Well, the 4 and the 100 in the first one cancel out to give us 25 on bottom. So that's x minus 3 squared over 25. Here the 25 and 100 cancel out to give us 4 on bottom. So y plus 2 squared over 4. And of course 100 over 100 is 0, or is 1. So now my center is at 3, negative 2. So right there. My horizontal axis, horizontal semi-axis is the square root of 25, which is 5 units long. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My vertical semi-axis is the square root of 4, or 2 units. So 1, 2, 1, 2. So this ellipse is drastically elongated in the horizontal direction. If I wanted to find the foci, a squared minus b squared equals c squared. A is the longer one, so that'd be the 25, minus the 4 is 21. So c squared equals 21, which means c equals the square root of 21, which is 4 point something. So that's going to be somewhere in here for my foci. So that would be at 3 minus the square root of 21, comma, negative 2, and 3 plus the square root of 21, comma, negative 2, are the foci. Okay, so the last few are asking us to go the other direction. For any questions on the graphing ones? Okay, good. So now these last few questions, and like I said, I realized number 5 was cut off, so you couldn't do 5. But they're asking us to come up with the equation. If my vertices are 14, 3 and negative 12, 3. So I'm just going to sketch that out. 14, 3 and negative 12, 3. Well, that gives me a distance between them of 26 units, which means 13 is equal to A. That's my semi-horizontal axis. My foci are at 13, 3 and negative 11, 3. So the distance between those foci from negative 11 to 13 is 24 units. So half of that would be 12 is equal to C. So I need to find B yet. To find B, remember, A squared minus B squared equals C squared. So A squared, and I know that this is A because the foci go in the same direction. If the foci went in a different direction, then that would have to be B. So 13 squared is 169 minus B squared equals 12 squared is 144. Well, if we do the manipulation there, we get B squared is 25 or B equals 5. So what we have here, I'm going to erase my little graph over here. We have A equals 13 and B equals 5. So from that I can make my equation. And of course the center has to be directly between the foci. So between those 2 points is actually going to be at 1, 3. So my equation, x minus 1, because the x coordinate is at 1 of the center, squared, over A squared. So since A is 13, A squared is 169. Plus y, the y coordinate is at 3 for the center, so y minus 3 squared over b is 5, so 5 squared is 25. Of course, equals 1. So there is that equation. Now I should have said graphing equation. I said standard equations, not standard form. If I had said standard form, we'd want it worked out like this. But the standard equation for graphing an ellipse is in this form. So number 4 is going to be similar. We have endpoints for the semi-major axis, or for the major axis, are at 3, 4, and 3, -6. The endpoints for the minor axis are at 6, -1, and 0, -1. That would be our ellipse. This is 3 units here. This is, looks like 5 units there. So that means the center, of course, looks to be at 3, -1. So we have x minus 3 squared over, in the x direction it's 3, so the 3 squared is 9, plus y plus 1, since that's at -1 squared, over 5 squared is 25, equals 1. Now from the 2 examples we just did, number 5 here would be pretty simple to do. That's why I put it off the screen so we can do it really quickly together. Our center here is obviously at -3, 2. The horizontal semi-axis is 1, 2, 3 units long. 1, 2, 3 units long. The vertical semi-axis, 1, 2, 1, 2. So it's 2 units long. So that's saying our equation is going to be x minus the x coordinate of the center. So the x coordinate of the center is -3, so that ends up being x plus 3 squared over the horizontal semi-axis squared. So the horizontal semi-axis is 3, so 3 squared is 9. Plus y minus the y coordinate of the center, so that's 2, so y minus 2 squared over the vertical semi-axis squared. So the vertical semi-axis is 2. 2 squared makes 4. Equals 1. For an ellipse, they always have to add up to 1. So any questions off of those 5 problems or anything off the homework from last week that you want me to go over? Okay. So today we're going to continue on with these conic sections. If I was a better artist, I could draw them out for you. The reason they're called conic sections, I'll do an attempt here to draw them out. We'll see. No guarantees on the quality of my artwork. If you have 2 cones that are tip to tip like this, a circle is created by an intersecting plane that cuts straight through. You can see when that intersects this cone, it cuts out a circle. The ellipses that we did were created by a plane that intersects at an angle. So you can see the shape that that's going to cut out is going to be an ellipse. It's going to be elongated according to the angle of that plane. The steeper the plane, the more it's elongated. We've talked about parabolas. A parabola is created by a plane that's parallel to one of the sides of the cones. So the plane might come in like this, parallel to this side of the cone. So it only intersects the cone and a certain edge. That creates the parabola where that plane intersects it. And then the one we're going to look at today first, we're going to look at parabolas today before we're done, but the one we're going to look at first today is parallel to the axis of the cones. The axis of the cones would go right down through the middle here. So parallel to that would be just another plane that's straight up and down. So that plane, you can see, intersects. It's going to look kind of like a parabola up top and kind of like a parabola down below. It's going to form something that looks like that. Of course, the closer it is to the axis, the closer those two curves are together. And that's called the hyperbola. So a hyperbola is the first one we're going to look at today. A hyperbola is almost like the inverse of an ellipse. Standard form of an equation for a hyperbola notice that looks very much like the standard equation for an ellipse, with one big difference. The ellipse was plus. The hyperbola is minus. Now, because of that, on the ellipse, we always put x and then y, and we could tell which direction the ellipse went by which one of these numbers was larger, whether a was larger or b was larger. That gave us the length of the axis in the horizontal and vertical direction. That told us which direction the ellipse was stretched out in. Well, a hyperbola can either open up and down like this, or it can open side to side. And the way we can tell which direction it opens, whether it's a vertical opening or horizontal opening, and the technical term we use is transverse axis. Whether we have a vertical transverse axis like that or a horizontal transverse axis like this one, is which one comes first in our equation. This one here, because x is first in the equation, the x is positive, the x squared is positive technically, it's a horizontal transverse axis. If the y squared is positive, then we've got that vertical transverse axis. So now many of the characteristics of the ellipse follow up in the hyperbola. So before we get deep into the little pieces of the hyperbola, let's just take 1 second to review the pieces of the ellipse. So if I have x minus 2 squared over 25 plus y plus 3 squared over 9 equals 1. My ellipse is going to have a center at 2, negative 3. The horizontal semi-axis is the square root of 25, or 5 units long. The vertical semi-axis is the square root of 9, or 3 units long. We can almost picture this as a box or rectangle created with those dimensions, and our ellipse fits right inside of it, tangent to all 4 sides of that rectangle. And there's our ellipse. And of course we had the foci, which was a squared minus b squared. So whichever one's larger, 25, minus whichever one's smaller than 9, is 16. So c squared equals 16, giving us that c is 4. So we have our foci, 4 units from the center in either direction along whichever axis is the longest. In this case, that is the horizontal axis. Well, for a hyperbola, and recall, by the way, that the definition of that ellipse was all points whose sum of the distances from 2 points, in other words, from the foci, is constant. So any point on that ellipse, if I pick a point here, that distance to that focus, adding them together will be the same as if I pick a point here and I add that distance to that focus and that distance to that focus. Those sums will be the same. A hyperbola is a set of all points whose difference in distance from 2 points, in other words, from the foci, is a constant. So what that means is if I have 2 points, my foci, if I pick a point that's going to be on that hyperbola, the difference in distance between those points is a constant. So this distance here and that distance here, the difference between them is going to be the same. So I can pick a point over here. It's further from this point. Well, the distance from this point is that distance plus whatever the difference was on those first two. It's a little bit harder to imagine the difference being constant than it is the sum being constant. With an ellipse, you can just put 2 pegs at the foci and a string of a constant length and use that to run your pen. Here it's not quite so convenient. But if we look at our equation, and I'm just going to put some numbers down here. X minus 2 squared over 16 minus y plus 1 squared over 9 equals 1. First of all, the x is first. The x squared term is positive. So that means this is going to be horizontal. So we don't tell whether it's horizontal or vertical by which one's the larger number. We tell whether it's horizontal or vertical by which variable is the positive term. The x term is positive. That tells us this one is horizontal. So on our graph, we know that we're going to be, looking something like that. Now the center is still going to be found the same way. The center is going to be at 2, -1, because it's x minus 2 and y plus 1, or y minus a negative 1. That's our center. In the horizontal direction, the 16 is under the x squared term. The square root of 16, of course, is 4. Oops. So in the horizontal direction, we go 4 units to either side of that center. In the vertical direction, the y squared is over the 9, so the square root of 9 is 3. So we go 3 units above and 3 units below that center. Now, just like we did for the ellipse, I'm going to draw in a box, a rectangle, at those dimensions. The difference is, instead of the ellipse, where the ellipse was contained inside that box and tangent on all 4 sides, the hyperbola is totally outside of that box. What this box actually defines, first thing it defines, is a set of asymptotes. The asymptotes go corner to corner through this box. So lower left to upper right, that's an asymptote. Of course, it goes through the center and then through those corners. Like that. And that would go the other direction as well, through these corners. So our hyperbola is going to approach those asymptotes. Next, we need to find our foci. The vertex, since we know this is going to be horizontal, it touches that box on the left and right side. So it's still tangent, just only on 2 sides. At this point, we could draw in our hyperbola if we wanted to. It's going to look basically like this. That's our vertex on the right side. It opens up and asymptotic, so in other words, it approaches that line on either side. Same over here. It opens up and it approaches those asymptotes above and below like that. So there's our hyperbola. We still need to find the focus. For a hyperbola, the focus is not a squared minus b squared, but it's a squared plus b squared equals c squared. So a squared here was 16. B squared was 9. 16 plus 9 is 25 equals c squared. Tells us that c equals 5. So that means we go 5 units on either side of the center. Those are the foci. So the focus over here, the center here was at 2, -1, remember. 5 units this way would put us at 7, -1. 5 units this way would put us at -3, -1 for our foci. Well, let's look at some examples of hyperbolas to graph. So this one here, we got y minus 3 squared over 25 minus x plus 2 squared over 144. So first thing I want to look at is our center. Remember, the center is the x coordinate is subtracted from the x value. X plus 2 means that the x coordinate's a -2. Y coordinate comes from what's subtracted from the y value. Y minus 3 makes the y coordinate a positive 3. So we're at negative 2. Positive 3 is our center. Now, since y is first here, this tells us that this has a vertical transverse axis. In other words, the hyperbola opens up and down like this. A there is 5, or a squared is 25, so a, the square root of 25 is 5. So we're going to go up 5 from there. 1, 2, 3, 4, 4, 5. And we're going to go down 5. 1, 2, 3, 4, 5. So those are going to be the top and bottom of our box. Here, the b term, b squared is 144, so the square root of 144 is 12. That tells us we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. Got a little long on some of those. Let me do that again. To the left. And that's our box. So our asymptotes go through the center and through opposite corners of that box, like that. And like that. So as we saw before, we already have basically the information to sketch our hyperbola, because the vertex of the lower one is going to be at that box, tangent to the box, going like that, approaching the asymptotes. The one on top, again going out, approaching the asymptotes. We still need to do the foci. Though the foci here, we have 25 squared plus 144 squared equals c squared. Sorry, not 25 squared, but 25 plus 144. A is 5, so a squared is 25. B is 12, so b squared is 144. That adds up to 169 equals c squared. So if we square root that, we get that 13 equals c. So that means the focus is 13 units from the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the focus on the lower side is way down there. On the upper side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Way up here. You might notice that the wider the hyperbola is, the further the focus is from the vertex of the hyperbola. So now that we've seen a couple of examples, I want to talk about the asymptotes a little more. First thing I want to talk about is their slope. The slope of the asymptote, if I look at this triangle right here, the slope of that asymptote is simply this value here, which was 5, over this value here, which was 12. Now, depending on how you define A and B, and this textbook actually defines it so that B always stays with the Y and A always stays with the X, rather than making one of them always the transverse axis and the other one always the non-transverse axis. So this is always the B lift here, and this is the A here. So the slope of that is simply B over A. rise over run. So the slope of the other one here, this is going to have a slope of negative b over a. And of course it goes through the center here, and that of course has coordinate of hk, which comes from the numbers being subtracted from y and x. So for this hyperbola, since that center was at negative 2, 3, we can find the equations of those asymptotes. The first asymptote, since b is 5 and a is 12, has a slope of 5 over 12 and goes through the point negative 2, 3. The first equation y minus 3 equals 5/12 times x plus 2. That's our point slope form of a linear equation for that line. Remember, if we have any point on the line, it's y minus the y-coordinate. The y-coordinate was 3. X minus the x-coordinate. The x-coordinate was negative 2, so x minus the negative 2 is x plus 2. And then the slope multiplies that x-coordinate. And of course, the other line for the other asymptote, it's still y minus 3 equals, but the slope is now negative 5 over 12, x plus 2. So it goes through the same point, the slope is just negative. So let's define, we have two general forms for the hyperbola. So x minus h squared over a squared minus y minus k squared over b squared equals 1. In this general form, the transverse axis is horizontal because the x is the positive term. The center is at HK. The vertices are at H minus A, K, and H plus A, K. What that's saying is that A here tells us from the center how far we go to the left and the right. The asymptotes y minus k equals b over a times x minus h, and y minus k equals negative b over a times x minus h. The other general form we have is with the y term coming first. K still stays with the y, and we're going to keep b with the y. This textbook keeps b with the y as well. Minus x minus h stays with the x, and the a squared stays with the x as well. So for this one, the transverse axis is vertical because it is the y term that is positive. The center doesn't change. Center is still at HK. The vertices do change, however. Now from the center, the x-coordinate doesn't change, the y-coordinate does. We go from K minus B to HK plus B as our coordinates of our vertices. And our asymptotes still have the exact same equations. So I'm not going to rewrite those again. So given what we know about these, let's find from this equation y minus 2 squared over 36 minus x plus 1 squared over 49 equals 1. I want to find the center, vertices, foci, and the asymptotes, equations of the asymptotes. So our center, you probably already have this down. Our center here is -1, 2. Remember, the x-coordinate is with the x, so it's x plus 1. So it's technically it's x minus a -1. So the x-coordinate is -1. Of course, the y-coordinate is with the y. Y minus 2 means that that y-coordinate is 2. Now, since y is the positive term here, that tells us our transverse axis is vertical. So that means B here is going to define our vertices. The square root of 36 would be 6. So to find our vertices, we add that to the y-coordinate of the center and subtract it from the y-coordinate of the center. So the x-coordinate stays the same. Since our center is somewhere in here, and our hyperbola opens like that, the one vertex is above it, one vertex is below it. So the lower one is going to be 2 minus 6, or -4, so at -1, -4. The other one, our x-coordinate still stays -1. 2 plus 6 is going to be 8. So our vertices are at -1, -4, and -1, 8. Our foci. Well, again, for the foci, the x-coordinate is going to stay -1. Because the foci are going to be on that axis, that transverse vertical axis as well. We need to find the distance for the foci. So it's going to be a squared plus b squared. Well, a squared is 49. B squared is 36. That adds up to c squared. If I add those, that ends up being 85 is c squared. So c is the square root of 85, which is 9.22. So if I subtract, again from the center, from the 2 there, if I subtract 9.22, I get -7.22. If I add 9.22, I've got 11.22. That's the coordinates of my foci. Or I could have just put in, 2 minus 2 minus the square root of 85 and 2 plus the square root of 85 would have been accurate as well. If they want the exact coordinates of the foci, you would have to use those radicals. The equations of the asymptotes. Well, b is 6, a is 7. So the slope, one is going to be 6/7, the other one's going to be a negative 6/7. And it goes through that center of -2 or -1, 2. So for our first asymptote, it's y minus 2 equals 6/7 times x plus 1. And for the other one, it's y minus 2 equals negative 6/7 times x plus 1. Okay, it is 10:22. Let's go ahead and take our break. We'll come back at 10:30 and we will continue.